our liaison, I guess you could call him, from Loma Linda. He sent us a couple of videos showing that it was working because he was super excited. So like the first day he got it and opened it, he was like, it works! And then maybe like an hour and a half later, we get a video of him already testing it and using it. Hi, my name is Adrian and I'm a fourth year mechanical engineering student.
Hi, my name is Koliadko and I'm a fourth year computer engineering student. Our senior design project was called hand-controlled ventilation. I guess normally when you want to do manual ventilation, you'd use one of these, and it can make a respiratory technician tired by just, doing this all the time. So this allowed them to just push a button and deliver a breath to a patient instead of having to use a back valve mask.
Hello, my name is Matias Soto. I'm the Director of Innovation and Entrepreneurship here at Andrews University, and I was involved in the ventilation project as overseeing the industry lab, developing the relationship with Loma Linda University, and acting as a liaison between the students and the original inventors of this technology at Loma Linda. So we selected that project initially, we assigned a team, and we realized that the problem he had was what happens if if a patient stops breathing, is connected to the mechanical ventilator, and I need to rush to give him manual ventilation. Other clinicians also rush in, and they're kind of getting in the way of the professional trying to give that manual ventilation. The student solution was, can I create some sort of remote control way to control this mechanical ventilator?
So essentially, we made a system that would connect to a mechanical ventilator and a remote so that somebody could trigger breaths from a safe distance away. So it was to protect respiratory technicians and patients.
My name is Gunnar Løviden. I teach here in the engineering department. I am the current chair of the School of Engineering. This particular project was brought by Paul Casillas. He's a respiratory therapist. He teaches at Loma Linda. And so this is a project that would then require some custom communication, interacting with the machine, and they actually pulled it off. They sent the prototype to Loma Linda, he tested it, and it worked the first time.
Yeah, for me, I'm not much of a mechanical guy, and typically when I do projects, I do all the electronics, and then I don't want to do the mechanical part. So it was nice having the work separated between the different concentrations, because I don't know if I would have been able to do it if I had to sign this whole project myself.
When I saw, especially who I was paired with, I was like, yes. Because I knew I wasn't gonna have to do all of the work, because my partner's amazing, so.
So part of it is there's a natural way to partition things in engineering sometimes, different systems, a mechanical system versus an electrical system. And a lot of times you have specialists in those areas, a mechanical engineer, an electrical engineer, and so on, right? At the beginning of the project, especially in the design part of it, there has to be a lot of consensus as to, well, what direction we are taking.
This is our final designs. For these designs, they didn't start out like this. So when I was working on them, there was a little confusion, a little mix-up, and all of the information got lost. So I lost the files, all the designs, everything. So I had to restart.
Well, we had to do some upgrades to our computers, and we didn't communicate clearly enough. So we upgraded the computers in our creative space and in the basement that had the drawing software on them. And as a result, one of the students working on this project lost all of his preliminary mechanical drawings overnight. He wasn't too happy about that.
I'd for sure back up my files. Yeah, I don't know why I didn't start with that, but I got taught a lesson very, very quickly.
When I asked him about it much later, he sort of admitted, yeah, I had to recreate everything, but I did it better. So it is not to be recommended, it's not ideal, but when you see a student take adversity like that and looking it straight in the face and using it to his advantage, that's good to see.
I think the project management was done really well. Our project manager, Michael Mason, he was the project manager for all the projects, and he was very good at keeping us on track, and if we had questions about what we should do to meet deadlines and stuff, he always had good advice for that.
I think we got a lot of really good experience from it too, because it's one thing to come up with a product and be like testing it, but it's another thing to have like the formatting of the real world, like with the project management and making sure that all of our deadlines that we had were met. I think that was really helpful for our future.
I'm very excited about this program because it provides experiences to students. It allows us to develop closer partnerships with industry organizations. So it has multiple benefits on those levels. We actually are hoping or expecting to receive a grant from the National Science Foundation to help expand this program to develop more industry relations, closer ties, and through that effort bring more benefit, more projects to our students and faculty.
I think it would be cool if it was actually used like in real life in a hospital. I guess I've never actually built something that went that far into production, so I think that would be really cool if it could go and be used and help people.
Especially where it is right now, I think it's close enough to like a final project or product that we can start going through like the channels to get it approved, so that we can start using it in hospitals, because how highly the person at Loma Linda was talking about it, he's really excited to try and get it approved and start using it. Yeah. So for production, we would make a few changes, but it's really close, and we're hoping it'll help a lot of people.